The universe is an endless playground of the unknown, a place where reality often bends into shapes we can barely comprehend. Think about it. Every time we point our telescopes toward the stars, we uncover something that challenges everything we thought we knew. From stars that vanish without a trace to galaxies that spin in impossible ways, the cosmos is full of events so bizarre, they seem ripped straight from science fiction. And yet, these aren't stories crafted by imagination, they're real, documented mysteries that astronomers are still struggling to explain. What if I told you there are at least 25 cosmic phenomena so strange they defy logic itself? Picture this, a star flickering erratically, dimming and brightening in ways that no known natural process should allow, or a black hole shooting out jets of energy so powerful they could light up entire galaxies. These aren't just anomalies, they're cosmic puzzles waiting to be solved, each one a reminder of how little we truly understand about the vast expanse beyond our planet. And the deeper we look, the more questions we find. Why do some celestial objects behave in ways that break every rule we've written? What unseen forces are at play in the darkest corners of space? That's exactly what we're diving into today, a journey through the most mind-bending, head-scratching, and downright unbelievable events ever observed in the cosmos. These aren't just quirks of astronomy, they're glimpses into the universe's most well-kept secrets. So if you've ever stared up at the night sky and wondered what else might be out there, things beyond our wildest theories, you're in the right place. Because by the end of this, you'll see the universe in a whole new light, where the only certainty is that reality is far stranger than fiction, ready to explore. Let's begin. Among all the cosmic mysteries that have left astronomers scratching their heads, few are as tantalizing or as frustrating as the WOW signal. On the night of August 15, 1977, a radio telescope at Ohio State University's Big Ear Observatory picked up something extraordinary, a pulse of radiation so powerful, so unexpected, that the astronomer who discovered it scribbled, "Wow," in the margins of the printout, and that's how it got its name. For 72 seconds, this signal blared from the direction of the constellation Sagittarius, blasting at a frequency that scientists had long theorized might be used by extraterrestrial civilizations. Then, just as suddenly as it appeared, it vanished. What made this signal so special was its intensity. It was 30 times stronger than the background noise of space, matching the exact frequency of hydrogen, the most common element in the universe. If an alien civilization wanted to send a cosmic hello, this would be the perfect way to do it. But here's the catch: despite decades of searching, we've never heard it again. Not once. Theories about the WOW signal range from the mundane to the mind-blowing. Some say it could have been a passing comet reflecting radio waves, though later studies have cast doubt on that idea. Others suggest it might have been a natural phenomenon we don't yet understand, maybe some exotic cosmic event emitting radiation in ways we've never seen. And then, of course, there's the possibility that it really was an attempt at contact, a single, fleeting message from the depths of space, never repeated. What keeps the WOW signal so fascinating isn't just the mystery of what caused it, it's the fact that, even after all these years, we still don't have a definitive answer. No natural explanation fully fits, and no signal like it has ever been detected since. It stands as one of the most compelling pieces of evidence that maybe, just maybe, we're not alone in this vast universe. And until we hear it again, if we ever do, it remains a cosmic whisper, a ghost of a signal that continues to haunt the search for extraterrestrial intelligence. If you think the WOW signal was puzzling, wait until you hear about Tabby's star, officially named KIC 8462852. This distant sun in the constellation Cygnus has baffled astronomers like few others because it doesn't behave like a star should. Most stars flicker gently as planets pass in front of them, causing predictable, subtle dips in brightness. But Tabby's star, it's a cosmic wildcard, dimming erratically by as much as 22% at times, a drop so extreme it defies every conventional explanation. The mystery began in 2015 when citizen scientists combing through data from NASA, a Kepler telescope, flagged something bizarre. Instead of the usual neat periodic dips, this star's light curves looked chaotic, like someone had taken a pair of cosmic scissors to the graph. The dips weren't just irregular, they were asymmetrical, sometimes lasting for days, other times vanishing within hours. And here's the kicker: historical records showed the star had gradually dimmed by 14% over the past century. Stars don't just fade like that without a reason, yet no known natural process could account for it. Cue the theories, one of the most sensational, that we were looking at an alien megastructure, a Dyson swarm perhaps, built by an advanced civilization to harness the star's energy. The idea wasn't entirely far-fetched. After all, if a species needed vast amounts of power, surrounding their sun with solar collectors would make sense. And those jagged light patterns, they could be the shadows of partially constructed rings or panels moving unpredictably. Of course, scientists scrambled for less exotic explanations. Maybe it was a colossal cloud of dust and debris from a shattered planet or a swarm of comets. Or perhaps the star itself was behaving strangely, with internal dynamics we don't yet understand. Follow-up observations revealed the dimming was wavelength dependent, meaning some colors of light were blocked more than others. That pointed to dust, not solid megastructures, since dust scatters certain wavelengths more effectively. Yet even now, the case isn't closed. Recent studies suggest the dust explanation fits some but not all of the data. Some dips remain too sudden, too deep. And that century-long dimming still unexplained. Tabby's star keeps throwing curveballs, refusing to fit neatly into any box. It's a reminder that the universe loves a good mystery, and sometimes the most compelling answers aren't the ones we expect. Whether it's alien engineering or some bizarre natural phenomenon we've yet to discover, one thing's certain: this star isn't done surprising us. Now let's shift our gaze closer to home, to an enigma that's been orbiting Earth not just in space, but in the realm of conspiracy theories for decades. Meet the so-called Black Knight satellite, a shadowy object said to be an ancient alien probe silently watching us from the darkness above. The legend goes like this: an extraterrestrial artifact, possibly thousands of years old, has been circling our planet long before humans ever launched Sputnik. Some claim it's been transmitting signals, others insist it's proof of advanced civilizations visiting Earth in the distant past. But how much of this is grounded in reality and how much is pure myth? The story took root in the 1950s when newspapers reported unusual radio echoes detected by researcher Stormer, delayed signals that seemed to bounce off something mysterious in orbit. Then, in 1960, Time magazine mentioned an unidentified dark object tracked by the US Navy, which conspiracy theorists later latched onto as evidence. But the real spark came in 1998, when grainy footage from a NASA space shuttle mission appeared to show a strange, jagged object floating against the backdrop of Earth. The internet exploded with claims this was the Black Knight, finally captured on camera. Here's where things get interesting. NASA explanation: space debris, specifically a thermal blanket lost during an earlier mission. The irregular shape, just crumpled insulation reflecting sunlight. As for those radio echoes from the 50s, scientists attribute them to natural ionospheric phenomena or even secret military tech tests of the era. But if it's just space junk, why does the myth persist so stubbornly? Part of the allure is the way fragments of history get twisted into something grander. The Black Knight's legend stitches together unrelated events, misinterpreted data, lost equipment, even a Nikola Tesla experiment where he claimed to intercept strange radio pulses. Layer on viral internet lore, and you've got a modern myth that feels too tantalizing to dismiss outright. Yet every serious investigation, from astronomers to satellite trackers, concludes the same way: there's no mysterious alien object. The satellite doesn't match any stable orbit, and no verified signals trace back to it. But here's the twist: the myth endures because it taps into something deeper, our fascination with the idea that we're not alone and that clues might be hiding in plain sight. The black night isn't just about debris or thermal blankets. It's a mirror reflecting our hunger for cosmic mysteries, and in a way that makes it more than just a conspiracy. It's a cultural artifact, a story we keep telling because the universe feels richer when it holds secrets waiting to be uncovered. So while the satellite itself might be a bust, the legend, that's still very much in orbit. Fast radio bursts are like the universe playing an impossible game of cosmic Morse code. Blips of energy so powerful they outshine entire galaxies but vanish in less time than it takes to blink. Discovered in 2007, these bursts are among the most enigmatic phenomena in modern astronomy, packing more energy than the Sun emits in 80 years into a single millisecond. And the strangest part, some of them repeat, pulsing from the same corner of space at irregular intervals, as if something or someone is hitting a celestial reset button. Take FRB 121102, the first repeating fast radio burst ever detected. Unlike one-off bursts that flash and disappear, this one has been sending signals from a dwarf galaxy 3 billion light-years away since at least 2012. The pattern is erratic, sometimes going silent for months before firing off dozens of bursts in a single day. Astronomers have traced its origin to an extreme environment near a massive black hole or a neutron star, but even that doesn't fully explain the bizarre cadence. So what's causing these cosmic fireworks? One leading theory points to magnetars, a type of neutron star with a magnetic field 1 trillion times stronger than Earth. When these stars experience starquakes, sudden fractures in their crust, they might unleash torrents of radio waves. Another idea involves cosmic collisions, like two neutron stars merging or a black hole shredding a nearby star, releasing catastrophic bursts of energy. But the repeating patterns throw a wrench into these theories. Natural disasters in space don't usually happen on a schedule. Yet here we are, catching the same cosmic address blaring out signals years apart. Then there's the elephant in the room. Could these be artificial? The idea isn't as far-fetched as it sounds. The burst's intensity and brevity match what we'd expect from an interstellar beacon, or even a propulsion system harnessing radio waves to power alien spacecraft. Scientists have debated whether advanced civilizations might use FRBs as galactic lighthouses or unintentional leakage from their technology. But before you imagine alien radio stations, the consensus leans toward natural origins, with physics we're still unraveling. Recent breakthroughs have added new layers to the mystery. In 2020, astronomers detected an FRB inside our own galaxy, linked definitively to a magnetar. That was a eureka moment, proof that at least some bursts stem from these extreme stars. Yet the repeater bursts, with their odd, unpredictable rhythms, still defy easy explanation. Are we seeing multiple phenomena lumped together, or is there a unified theory waiting to be found? Every new detection peels back another layer of this cosmic onion. With telescopes like CHIME now scanning the skies around the clock, we're finding FRBs at an astonishing rate, some from regions of the universe we've never mapped. Each one is a breadcrumb hinting at processes we've yet to imagine. Whether it's magnetars cracking under pressure, black holes dancing with stars, or something even more extraordinary, one thing's clear: the universe has a flair for the dramatic, and fast radio bursts are its most cryptic encore. Far beyond the familiar swirl of our Milky Way, something massive is pulling entire galaxies toward it with a force we can't ignore, something we call the Great Attractor. Picture this: hundreds of thousands of galaxies, including our own, are drifting through space not randomly, but toward a single, mysterious point in the constellation Centaurus. The problem, we can't see it directly. This cosmic heavyweight lurks hidden behind what astronomers call the zone of avoidance, a region of sky obscured by the thick dust and stars of our galaxy's disk, blocking nearly 20% of our view into the universe beyond. The mystery began in the 1970s when scientists first noticed peculiar motions in nearby galaxies. Instead of expanding uniformly with the universe's flow, they were veering off course as if tugged by an invisible hand. Calculations revealed the culprit had to be colossal, a gravitational anchor with the mass of tens of thousands of Milky Ways. But scans of the area turned up only scattered galaxy clusters, nothing dense enough to explain the pull. This left astronomers with two possibilities. Either we're missing something massive lurking in that hidden zone, or the Great Attractor isn't the final destination but a stepping stone to something even grander. Enter the Laniakea supercluster. In 2014, researchers mapped the motions of thousands of galaxies and uncovered a jaw-dropping truth: the Great Attractor isn't acting alone. It's merely the heart of a vast cosmic web, a supercluster spanning 500 million light-years with galaxies flowing like rivers toward its gravitational well. But here's where it gets stranger. Beyond Laniakea, there's evidence of an even larger structure, a dark flow pulling superclusters toward the distant Shapley Attractor, a dense knot of galaxies over 600 million light-years away. So what is the Great Attractor? The leading theory suggests it's a confluence of several massive clusters like Norma and Able 3627, their combined gravity bending space-time on a staggering scale. Yet some argue there could be exotic factors at play, unseen dark matter concentrations, or even primordial flaws in the fabric of the universe left over from the Big Bang. Mapping this enigma has required ingenious workarounds. Infrared telescopes like Oumuamua pierce through dust clouds, while radio surveys trace hydrogen gas to reveal hidden galaxies. Each new glimpse chips away at the mystery, showing us a universe far more interconnected than we ever imagined. The Great Attractor isn't just a destination, it's a reminder that even the cosmos has currents pulling us toward discoveries we've yet to fully see. If the Great Attractor left you questioning how much of the universe remains unseen, brace yourself, because dark flow takes that mystery to an even more unsettling level. Imagine every galaxy cluster in our observable cosmos drifting not just toward a hidden mass, but toward something even farther beyond the cosmic horizon itself. This isn't just gravity at work, it's as if the universe has a secret current, tugging everything in one direction with a force we can't trace to any known structure. First detected in 2008, dark flow describes the peculiar motion of hundreds of galaxy clusters, all streaming at nearly 2 million miles per hour toward the same patch of sky near the constellations Centaurus and Vela. The kicker: there's nothing there, no supercluster, no dense knot of matter, nothing visible that could explain the pull. Scientists have scrambled for explanations. One possibility is that the flow stems from massive structures lurking in the unobservable universe regions so far away, their light hasn't had time to reach us since the Big Bang. Another theory, that our universe is uneven on scales we've never measured, with primordial fluctuations in space-time itself acting like cosmic tides. But the most controversial idea is that dark flow might be evidence of a neighboring universe, its gravity leaking into ours through some higher dimensional rift. While that sounds like sci-fi, it's a real hypothesis physicists have debated, because sometimes the wildest answers are the only ones that fit. Now, shift your focus from motion to temperature, specifically to a patch of sky so cold it defies everything we know about the early universe. Known as the CMB cold spot, this eerie void in the cosmic microwave background radiation spans nearly 2 billion light-years and clocks in at around 70 microkelvins colder than its surroundings. Discovered in 2004, it's not just a statistical fluke. Simulations show the odds of such a cold region forming naturally are about 1 in 50. So what carved this cosmic frostbite into the fabric of reality? One explanation points to a supervoid, an enormous, nearly empty region of space where matter is so sparse. Photons from the CMB lose energy as they travel through it, creating a cold imprint. But here's the catch: even the largest known voids can't fully account for the temperature drop. That's led theorists to propose something far more radical: that the cold spot might be a bruise left by a collision with another universe during the infancy of our own. In this scenario, our cosmos is just one bubble in a vast multiverse, and the cold spot marks where another bubble grazed ours, sapping energy at the point of contact. Skeptics argue it could simply be a rare density fluctuation, a cosmic coincidence. Yet the cold spot's sheer size and the inability of standard physics to explain it keep alternative ideas alive. Whether it's evidence of a multiverse or just a gaping hole in our understanding, one thing's certain: these anomalies, dark flow and the cold spot, are reminders that the universe might be playing by rules we haven't even discovered yet. And that's what makes them so thrilling. They're not just puzzles, they're potential keys to unlocking realities beyond our own. In October 2017, astronomers spotted something unprecedented: a visitor from another star system hurtling through our cosmic neighborhood at nearly 200,000 miles per hour. Named Oumuamua, Hawaiian for scout, this interstellar interloper defied every expectation. Most asteroids or comets follow predictable paths shaped by gravity and the glow of the sun. But Oumuamua, it had secrets. First, there was its shape, long and thin, like a cosmic cigar, with estimates suggesting it could be 10 times longer than it was wide. Nothing in our solar system looks like that. Then came the real shocker. As it sped away from the sun, it accelerated unexpectedly, as if pushed by an unseen force. Comets often get a speed boost from evaporating ice, but Oumuamua showed no visible tail or gas cloud. So what was nudging it forward? The scientific community scrambled for answers. One camp argued it was a rare type of comet, ejecting invisible hydrogen gas as it warmed. Others suggested it might be a fragment of a shattered planet, its odd shape carved by eons of cosmic erosion. But Harvard astrophysicist Avi Loeb proposed something far more provocative: that Oumuamua could be artificial, perhaps a solar sail from an alien civilization. His reasoning: the object's brightness varied dramatically as it tumbled, implying a flat, reflective surface, and that unexplained acceleration, perfectly consistent with sunlight pushing against a thin, manufactured sail. Critics were quick to dismiss the idea. They pointed out that extraordinary claims require extraordinary evidence, and Oumuamua's quirks, while puzzling, could still have natural explanations. The lack of radio signals or other signs of technology made the alien hypothesis a long shot. Yet Loeb held firm, arguing that science should remain open to all possibilities, especially when faced with anomalies. What makes Oumuamua so fascinating isn't just the debate. It's the reminder that our solar system isn't an isolated island. Objects like this likely pass through all the time. We've just never had the tools to catch them before. Now, with telescopes like the Vera Rubin Observatory coming online, we might soon find more interstellar visitors, each one a clue to the diversity of the cosmos. Whether Oumuamua was a weirdly shaped rock, a hydrogen iceberg, or something even more extraordinary, its brief flyby left us with a tantalizing thought. The universe is full of surprises, and sometimes the most intriguing answers lie just beyond our current understanding. We think of supernovas as the grand finales of stellar lives, explosions so violent they obliterate their stars in a single, catastrophic blast. But what if I told you some stars cheat death? Meet the zombie stars, cosmic oddities that refuse to die even after their supposed demise. These aren't just stellar remnants, they're celestial survivors, flickering back to life in ways that defy every textbook model of how stars should behave. Take Type Ix supernovas, for example. Unlike their more famous cousin, the Type Ia supernova, which leaves nothing behind but scattered debris, these explosions are the universe's failed fireworks. They're weaker, messier, and crucially, they sometimes leave their white dwarf progenitors partially intact. Imagine a bomb going off, but the fuse only burns halfway. Instead of complete annihilation, the star gets blown apart, yet somehow, a scorched, battered core remains, still shining faintly in the wreckage. How does this even happen? The leading theory involves a twisted cosmic dance between two stars. In a classic Type Ia supernova, a white dwarf siphons material from a companion until it hits a critical mass, triggering a runaway thermonuclear explosion. But with Type Ix, the detonation might misfire. The explosion could be lopsided, or perhaps the white dwarf isn't completely consumed, leaving a mangled remnant behind, half dead, half alive, like a stellar Frankenstein's monster. But here's where it gets even stranger. Some of these zombie stars don't just fade quietly into the cosmic background. Observations suggest they might reignite, pulling material back onto their wounded cores and flaring up centuries later. It's as if the star's death was just an intermission, not the final act. This throws a wrench into our understanding of stellar life cycles. If stars can survive supernovas or even come back to life afterward, what else have we gotten wrong about how they die? Could there be other overlooked survivors lurking in the debris of past explosions? The discovery of zombie stars forces us to rewrite the rules, proving that even in death, the universe has a flair for the unexpected. These cosmic phoenixes aren't just scientific curiosities. They're a reminder that the universe is always more inventive than our theories. And if stars can cheat death, what other celestial miracles are we still missing? We live in a galaxy packed with hundreds of billions of stars, many hosting planets in the so-called Goldilocks zone. Not too hot, not too cold, just right for life as we know it. With odds like that, the universe should be teeming with civilizations. So where is everyone? This is the Fermi paradox, a question that's haunted scientists since physicist Enrico Fermi first posed it over lunch in 1950. If alien life is statistically probable, why haven't we found a single trace of it? The silence is deafening. Despite decades of scanning the skies with radio telescopes, sifting through petabytes of data for patterns, and discovering thousands of exoplanets in habitable zones, we've encountered nothing but static. No signals, no artifacts, no visitors. It's as if the universe is a vast, empty theater where we're the only audience. This contradiction between overwhelming probability and zero evidence fuels some of the most gripping theories in astrobiology. Take the Great Filter. This chilling idea suggests there's some catastrophic hurdle that prevents life from advancing to interstellar levels. Maybe it's the rise of self-destructive technology like nuclear war or runaway artificial intelligence. Or perhaps it's something more subtle, a biological bottleneck where complex life almost never emerges from single-celled organisms. The scary part, we don't know if we've already passed the filter or if it's still ahead of us, lurking like a cosmic tripwire. Then there's the zoo hypothesis, which flips the script entirely. Imagine Earth as a planetary exhibit, deliberately quarantined by advanced civilizations observing us like wildlife in a celestial safari park. They might be waiting for us to reach a certain technological or ethical milestone before making contact. It's an unsettling thought that we could be surrounded by silent watchers, hidden by technologies we can't even fathom. Recent exoplanet discoveries add layers to the puzzle. Worlds like Proxima Centauri b, just 4 light-years away, or the 7 Earth-sized planets orbiting TRAPPIST-1, prove that habitable real estate is everywhere. Yet none show signs of civilization. Some argue we're simply too early, that life is rare, and we're among the first to emerge in a young universe. Others suggest we're looking for the wrong things, like radio waves, when advanced societies might have moved to neutrino communication or quantum networks. The truth is, the Fermi paradox isn't just about aliens. It's a mirror reflecting our own fragility and place in the cosmos. Every possible answer carries existential weight. If the great filter is behind us, we're cosmically lucky. If it's ahead, we might be doomed. And if the silence is by design, that changes everything. Until we know for sure, the paradox remains one of science's most profound mysteries, a question that doesn't just wonder about life out there, but forces us to confront what it means to be alive right here. If you thought galaxies were all spirals, ellipticals, or messy irregular blobs, Hoag's object will make you think again. Discovered in 1950 by astronomer Arthur Hoag, this celestial oddity is a galaxy unlike any other. A perfect glowing ring of blue stars encircling a golden core, floating in the void like a cosmic bullseye. At roughly 600 million light-years away in the constellation Serpens, it's so symmetrical, so eerily precise, that early astronomers suspected it might be an optical illusion. But Hubble's sharp eye confirmed it's real, and its existence throws a wrench into our understanding of how galaxies form. Most ring galaxies are the result of violent collisions. When one galaxy punches through the center of another, the gravitational shockwave sends stars and gas rippling outward, creating a temporary ring structure. But Hoag's object doesn't fit that story. There's no sign of a disrupting galaxy nearby, no debris trail hinting at a recent crash. Instead, it sits in serene isolation, a pristine loop that's lasted for billions of years. So if it wasn't born from chaos, how did this cosmic circle come to be? One theory suggests it's a product of accretion, a slow, steady accumulation of gas and stars over eons. Imagine a central bulge with a rotating disk of material around it. Instabilities in the disk could trigger star formation in waves, leaving older stars near the core and younger, brighter ones glittering along the outer edge. Another idea posits a long-ago collision so perfectly aligned that the debris settled into this flawless ring, with time erasing all traces of the Chinese letter. Yet neither explanation fully accounts for the symmetry. The ring isn't just roughly circular, it's mathematically precise, with near-uniform density and no visible distortions. What makes Hoag's object even stranger is that it's not alone. Peering deeper into the ring, astronomers spotted another distant ring galaxy, smaller and fainter, looped almost perfectly behind it. Could this be a clue that such structures are more common than we thought, or just a wild coincidence? Either way, the presence of two ring galaxies in the same line of sight deepens the mystery. This celestial enigma challenges our assumptions about galactic evolution. Maybe there are quieter, gentler ways for rings to form, processes we haven't yet imagined. Or perhaps Hoag's object is a rare survivor, a galactic fossil from an era when the universe worked by different rules. Whatever the truth, it stands as a reminder that the cosmos loves to defy categorization, serving up puzzles that push us to rethink everything we know. And for now, this perfect ring remains one of astronomy's most beautiful, unanswered questions. Among the countless nebulae painting the cosmos, few stand out as strikingly or as mysteriously as the red rectangle. Perched about 2,300 light-years away in the constellation Monoceros, this cosmic oddity looks less like a typical glowing gas cloud and more like a geometric masterpiece. Through the lens of the Hubble Space Telescope, it reveals an almost perfect X-shaped structure, its crimson arms stretching outward like beams of light caught in a celestial kaleidoscope. But the real surprise isn't just its shape, it's the bizarre chemistry at play inside. Most nebulae glow due to ionized gases, their colors dictated by familiar elements like hydrogen and oxygen. The red rectangle, however, defies expectations with spectral lines that don't match any known compounds. Dubbed unidentified infrared emission bands, these mysterious signals have baffled scientists for decades. Some theorize they come from complex organic molecules, perhaps even polycyclic aromatic hydrocarbons, the same compounds found in soot here on Earth. If true, this nebula could be a cosmic factory for the building blocks of life, churning out chemicals we've yet to fully understand. Then there's the structure itself. The X shape isn't random, it's the handiwork of a dying binary star system at its heart. As one of the stars nears the end of its life, shedding layers of gas and dust, its companion star funnels this material into opposing cones like twin fire hoses spraying into space. Over time, these outflows collide and flatten, sculpting that iconic rectangular silhouette. But even here, nature throws a curveball. The symmetry is too precise, too crisp, as if carved by an invisible cosmic chisel. What makes the red rectangle truly extraordinary is the interplay of forces shaping it. The binary stars don't just eject material, they do so in rhythmic pulses, creating concentric rings within the nebula like tree rings marking time. And that crimson hue, it's not just scattered light. It's the glow of those enigmatic molecules absorbing and re-emitting energy in ways we're still decoding. This nebula is more than a pretty anomaly, it's a laboratory for processes we've never seen elsewhere. From its unknown chemistry to its improbable geometry, it challenges our assumptions about how stars die and what they leave behind. Perhaps hidden in its glowing lattice lies a clue to how complex organic matter spreads through the universe, seeding the cosmos with the ingredients for life in the most unexpected ways. One thing's certain, the red rectangle refuses to fit neatly into any cosmic box, and that's exactly what makes it so mesmerizing. Imagine a hole in the universe so vast you could drop the entire Milky Way into it, and it would barely make a ripple. Welcome to the Boötes Void, a cosmic emptiness stretching 330 million light-years across, where galaxies are so few and far between. It's been called the Great Nothing. Located 700 million light-years from Earth in the constellation Boötes, this region isn't just sparsely populated, it's a desert on a scale that defies logic. While a typical chunk of space that size should contain around 2,000 galaxies, the Boötes Void holds fewer than 60. Standing at its edge, you'd peer into an abyss so dark and empty, it feels less like a part of our universe and more like a glitch in the cosmic code. So how does a void this colossal even exist? One leading theory suggests it's a supervoid, a natural bubble in the large-scale structure of the universe, where matter simply didn't clump together during the Big Bang's aftermath. Think of the cosmos as a foam of galaxy clusters with gaps where the bubbles meet. But the Boötes Void isn't just a gap, it's a chasm. Its sheer size strains the limits of what our models predict. Even the most extreme fluctuations in the early universe's density shouldn't have left a void this empty. That's led some cosmologists to propose a wilder idea. What if it's not a void at all, but the imprint of an ancient quantum fluctuation frozen in time? A ripple in space-time so profound it cleared out matter like a cosmic bulldozer. Then there's the unsettling implication. Voids like this might be more than oddities. They could be evidence of something fundamentally wrong with our understanding of gravity. Modified Newtonian dynamics, or MUND, challenges Einstein's relativity by suggesting gravity behaves differently on vast scales. If true, the Boötes Void's existence might not be a mystery but a clue, pointing toward physics we've yet to discover. But here's the twist, even this void isn't completely empty. The few galaxies that do call it home are oddballs themselves. Take the dim, isolated galaxy MCG plus 0102, drifting like a lone ship in an ocean of nothing. These stragglers raise new questions. Did they form here against all odds, or are they survivors from a time before the void consumed their neighbors? The Boötes Void forces us to confront how little we know about the universe's skeleton. Is it a cosmic accident, a sign of deeper physics, or something else entirely? With every unanswered question, it reminds us that the universe doesn't just hide its secrets in the light. Sometimes they're lurking in the darkness. Most planets play by the rules, dutifully orbiting their parent stars in predictable clockwork patterns. Then there are the cosmic renegades, rogue planets, flung from their homes by gravitational chaos to wander the galaxy alone, untethered to any sun. These interstellar nomads drift through the void in perpetual darkness, their surfaces frozen to unimaginable extremes. Yet what makes them truly remarkable isn't just their loneliness, it's that they might be far more common than we ever imagined. Some estimates suggest there could be billions, even trillions, of these free-floating worlds just in our Milky Way, outnumbering stars by as much as 20 to 1. Detecting something that emits no light of its own might seem impossible, but astronomers have developed ingenious methods to spot these shadowy drifters. Microlensing, where a planet's gravity briefly bends and magnifies the light of a distant star, has revealed dozens of rogue worlds. Others have been caught by their faint infrared glow, residual heat from their violent births lingering in the cold of space. In 2018, scientists even spotted one just 20 light-years away, a Jupiter-sized outcast drifting through our cosmic neighborhood. But here's where it gets fascinating. Rogue planets might not all be frozen wastelands. Tidal forces from their formation, radioactive decay, or thick insulating atmospheres could trap enough heat to sustain liquid water beneath icy crusts. Imagine vast subsurface oceans shielded from the cold by layers of ice, where life might cling to hydrothermal vents, much like extremophiles do in Earth's deepest trenches. If that's possible, these wandering worlds could be stealthy arcs of life, carrying biological seeds between stars. Then there's the spine-chilling thought: could Earth itself have once been rogue? The Nomad Earth hypothesis dares to suggest that our planet might have formed in another system, ejected by some ancient catastrophe, only to be captured by the sun's gravity. It's a long shot, but traces of our solar system's chaotic past, like the odd tilt of Uranus or the existence of the hypothetical planet 9, hint at turbulent gravitational shuffles. If true, we might all be descendants of cosmic castaways, living on a world that once knew no sunrise. Rogue planets shatter our assumptions about what a planet can be. They challenge us to rethink where life could hide and how solar systems evolve. Whether they're frozen orphans or secret oases, one thing's clear: the galaxy is teeming with these invisible travelers, and each one holds a story written in darkness. Deep in the constellation Serpens, about 4,000 light-years from Earth, orbits a planet that would make any jeweler drool: PSR J1719-1438b, a world likely sculpted from solid diamond. Imagine a celestial gemstone 5 times the size of Earth, glittering under the harsh glare of its dead star host, a millisecond pulsar spinning at nearly 10,000 revolutions per minute. This isn't science fiction, it's one of the universe's most extravagant natural wonders, forged in the aftermath of stellar catastrophe. The story begins with a binary star system, 2 cosmic dance partners orbiting each other in tight synchrony. One star, more massive than the other, exhausted its fuel first, swelling into a red giant before collapsing into a dense white dwarf, a hot, Earth-sized ember of carbon and oxygen. But when its companion star reached the end of its life, it didn't go quietly. It exploded as a supernova, its core condensing into a pulsar, a city-sized neutron star emitting beams of radiation like a lighthouse. The shockwaves from this detonation should have vaporized the white dwarf companion, but against all odds a fragment survived. Here's where physics gets poetic. The white dwarf, stripped of its outer layers by the pulsar's gravitational pull, was whittled down to a skeleton of crystallized carbon. Under pressures 1,000,000 times greater than Earth's atmosphere, that carbon was crushed into diamond, an entire planet compressed into a crystalline sphere. Scientists estimate its density at nearly 20 times that of Jupiter, meaning a teaspoon of its material would weigh more than a car. But PSR J1719-1438b isn't just a cosmic trophy. It's a glimpse into stellar alchemy. The pulsar's gravity is so precise, its rhythmic pulses arrive with atomic clock regularity. Any wobble in that timing betrays the presence of an orbiting companion, and in this case the data revealed a planet so small and dense, only Diamond could explain its composition. Yet mysteries linger. How did the white dwarf remnant avoid complete annihilation? Could there be other diamond worlds circling pulsars waiting to be discovered? And what would such a planet's surface even look like? Hypothetical models suggest an eerie landscape. No atmosphere, no molten core, just an endless plain of diamond latticework shimmering under the pulsar's relentless radiation. This celestial jewel challenges our notions of planetary diversity. It proves that under extreme enough conditions, the universe can craft worlds far stranger than anything we've dreamed up. And while we'll never mine its glittering surface, PSR J1719-1438b stands as a glittering monument to the cosmos's boundless creativity, a diamond forged not in Earth's mantle, but in the heart of a dying star. Our galaxy isn't the serene cosmic island it appears to be. It's a predator. The Milky Way has grown to its enormous size not just by birthing stars, but by devouring its neighbors in a process as dramatic as it sounds: galactic cannibalism. One of its most famous meals was the Gaia Enceladus galaxy, a dwarf system that met its end roughly 10 billion years ago. Astronomers pieced together this ancient crime scene by studying the motions and compositions of stars in our galaxy's halo. Some move in odd, retrograde orbits, like celestial breadcrumbs leading back to a violent merger. Their chemical signatures lower in heavy elements compared to native Milky Way stars betray their foreign origins. This wasn't a peaceful assimilation. It was a cosmic collision that likely sent stars careening into chaotic new orbits, reshaping our galaxy forever. But the Milky Way isn't alone in its carnivorous habits. Across the universe, larger galaxies grow by consuming smaller ones in a process called hierarchical merging. The Andromeda Galaxy, our nearest spiral neighbor, bears the scars of past feasts: two streams of stars ripped from dwarf galaxies, stretched into gossamer threads by gravity's relentless pull. Even the giant elliptical galaxies at the hearts of clusters, like Messier 87, owe their immense size to countless mergers, a cosmic food chain written in starlight. Now shift your gaze to NGC 1277, a galaxy that defies this violent norm. Nestled in the Perseus cluster 220 million light-years away, this compact, disc-shaped galaxy is a relic, a pristine survivor from the universe's chaotic youth. While most galaxies of its age were shredded and rebuilt by collisions, NGC 1277 stars have remained untouched for over 10 billion years, a frozen snapshot of the early cosmos. What makes this galaxy so special? Its stars orbit at dizzying speeds, hinting at the presence of a supermassive black hole so disproportionately large it outweighs some globular clusters. Yet despite this gravitational monster at its core, NGC 1277 never experienced the dramatic growth spurts of its peers. It's a cosmic time capsule, preserving the conditions of an era when the universe was just a fraction of its current age. The contrast between these two galactic tales couldn't be starker. One reveals the Milky Way as a relentless consumer growing through destruction. The other presents NGC 1277 as a solitary holdout, a relic resisting the forces that reshaped its kin. Together, they paint a vivid picture of the universe's dual nature, a place of both violent change and unexpected preservation, where the past lingers in the unlikeliest corners. Just when astronomers thought they'd seen it all, the cosmos served up another curveball, something so bizarre, even the scientists who discovered it initially doubted their own data. Meet the odd radio circles, or ORC, colossal rings of radio emission spanning hundreds of thousands of light years, drifting through space like ghostly halos with no clear origin. When the Australian Square Kilometre Array Pathfinder first spotted these faint but enormous structures in 2020, researchers were floored. These weren't just blobs or smudges. they were near-perfect circles, some large enough to swallow entire galaxies whole, yet completely invisible in optical, infrared, or X-ray light. The leading theory suggests ORCs might be the aftermath of cataclysmic intergalactic explosions. Picture two supermassive black holes at the centers of merging galaxies, spiraling toward each other until they collide with unimaginable force. The resulting shockwave could blast outward in a spherical bubble, lighting up intergalactic gas like a neon sign in radio frequencies. But there's a hitch: no known galaxy mergers nearby match the positions of these circles. If these are cosmic echoes, they're coming from events we haven't witnessed yet. Then there's the wild card: wormholes. Some theorists propose that ORCs could be the mouths of Einstein-Rosen bridges, tunnels through space-time predicted by general relativity but never observed. If a wormhole's throat were threaded with magnetic fields, it might funnel charged particles into glowing rings at its entrance. It's a long shot, but the sheer symmetry of ORCs keeps this idea on the table. After all, nature rarely creates perfect circles without a reason. What makes these structures even stranger is how few we've found. Only a handful have been confirmed, suggesting either they're incredibly rare or vanishingly short-lived. Some might even be relics from the early universe, fossils of an era when conditions allowed for phenomena we can't recreate today. Every new observation deepens the mystery. Recent studies reveal some ORCs have galaxies at their centers, but others float in empty space. Some seem to glow brighter at the edges like cosmic smoke rings, while others pulse faintly with no discernible pattern. It's as if the universe invented a new kind of celestial object and forgot to give us the manual. Whether they're shockwaves from unseen apocalypses, portals to other dimensions, or something even more exotic, ORCs remind us that the universe still holds cards it hasn't played yet. And as telescopes grow more sensitive, we might soon find these enigmatic circles are just the first whispers of a much bigger secret. Astronomers have long thought they understood the rules of black hole formation until LB1 crashed the party. This cosmic heavyweight, lurking about 15,000 light-years away in the constellation Gemini, defies every expectation. Clocking in at a staggering 70 times the mass of our Sun, LB1 shouldn't exist. At least not according to everything we thought we knew about how stars die. Here's the problem: black holes like this are born from the collapse of massive stars. But based on stellar evolution models, a star that hefty would typically blow itself to pieces in a pair instability supernova, leaving nothing behind. Even if it somehow avoided total annihilation, the maximum mass for a black hole formed this way was thought to be around 50 solar masses. So how did LB1 get so big? Either our measurements are catastrophically wrong, or the universe is playing by rules we haven't discovered yet. When Chinese astronomers first announced LB1's discovery in 2019, the scientific community split into two camps. Skeptics argued the data must be flawed. Perhaps the black hole wasn't actually 70 solar masses, but instead a smaller black hole orbiting a star in a way that mimicked a single massive object. Others suggested the team might have misread the Doppler shifts in the companion star's light, exaggerating the black hole's gravitational pull. Follow-up observations only deepened the mystery. Independent teams confirmed the original findings, ruling out most measurement errors. LB1's mass was real, and so was the headache it gave theorists. This left astronomers scrambling for alternative explanations. Could LB1 be the product of two smaller black holes merging, a cosmic collision hidden in the distant past? That would explain its size, but such mergers usually produce telltale gravitational waves, ripples in space-time we'd detect with observatories like LIGO. No such signal matched LB1's location or age. Another possibility: the black hole might have gorged itself on gas and stars over eons, bulking up like a celestial bodybuilder. Yet LB1's surroundings show no signs of such a feeding frenzy. The most tantalizing theory suggests we're seeing the handiwork of dark matter stars, hypothetical objects where dark matter interactions fuel stellar processes in ways we don't yet understand. If true, LB1 could be the first clue to a shadowy sector of physics where dark matter reshapes how stars live and die. Whatever the answer, this impossible black hole forces us to rewrite the textbooks. It's a reminder that the universe doesn't care about our models. It'll keep surprising us, one cosmic rebel at a time. And until we crack LB1's secret, it stands as a gleaming question mark in the dark, daring us to think bigger. Most galaxies shine with the light of billions of stars, their spiral arms or elliptical halos glowing brightly against the cosmic dark. But Dragonfly 44 plays by different rules. This phantom of the cosmos, lurking 330 million light-years away in the Coma cluster, is the size of our Milky Way, yet emits less than 1% of its light. If you could stand in its midst, the night sky would appear nearly empty, dotted with just a handful of visible stars where there should be thousands. The reason this galaxy isn't missing its stars, it's missing the thing that should hold them together, normal matter. Dragonfly 44 is a galactic ghost, a vast structure where 99.99% of the mass comes from something invisible, dark matter. When astronomers first spotted Dragonfly 44 in 2015, they assumed it was a run-of-the-mill dwarf galaxy, but as they measured the motions of its sparse stars, they got a shock. Those stars were whipping around at dizzying speeds, far too fast to be anchored by the galaxy's faint glow alone. The only explanation, an enormous, unseen gravitational anchor, a halo of dark matter outweighing all visible material 10,000 to 1. To put that in perspective, if the Milky Way swapped its dark matter for Dragonfly's proportions, our galaxy's stars would fling into the void, unable to resist the spin. Yet somehow, this cosmic paradox holds itself together with nothing but shadow. What makes Dragonfly 44 so perplexing isn't just its darkness, it's how it challenges the very models meant to explain galaxy formation. According to standard cosmology, galaxies grow within halos of dark matter, their stars coalescing where gravity pools normal matter, but Dragonfly's ratio is extreme beyond prediction. It's as if someone took a Milky Way-sized dark matter scaffold and forgot to add the stars. Some theorists argue it might be a failed galaxy, one that somehow missed the memo to form luminous matter during the early universe. Others suggest it could be the remnant of a larger galaxy, stripped of its stars by tidal forces, leaving only its dark skeleton behind. But neither theory fully explains why this particular ghost survived while others like it, if they exist, remain unseen. Then there's the puzzle of the stars it does have. Unlike the dense clusters of typical galaxies, Dragonfly stars are spread thin, with vast deserts of emptiness between them. Yet they move in coordinated orbits, as if dancing to the tune of some invisible conductor. This suggests the dark matter isn't just present, it's perfectly smooth, distributed in a way that defies the clumpy, granular structure predicted by many simulations. If dark matter particles interact with each other, as some theories propose, Dragonfly's flawless halo might be evidence of their subtle interplay. Or perhaps it's telling us dark matter is even stranger than we thought, a substance that doesn't just avoid light but shapes space with whisper-soft precision. The discovery of Dragonfly 44 didn't just add another oddity to the cosmic menagerie, it forced astronomers to confront the limits of their understanding. Here was a galaxy that shouldn't exist by standard playbooks, yet there it was, lurking in plain sight. Its existence hints that the universe might be teeming with similar phantoms, galaxies so dark they've escaped detection. Future telescopes like the Vera Rubin Observatory could unveil more of these shadows, rewriting the census of the cosmos. Until then, Dragonfly 44 remains a silent enigma, a reminder that the universe's greatest mysteries aren't always hidden in the light. Sometimes they're woven into the dark itself. The pillars of creation stand as one of the most breathtaking images ever captured by the Hubble Space Telescope, towering spires of gas and dust stretching light years tall, cradling newborn stars in their swirling embrace. But here's the heart-wrenching twist. These cosmic monuments might already be gone, vanished, reduced to stardust by a catastrophe we can't even see yet. The evidence comes from infrared observations of the Eagle Nebula, where the pillars reside. Astronomers have detected the faint echoes of a shockwave rippling through the region, likely unleashed by a nearby supernova explosion thousands of years ago. Given the nebula's 7,000 light-year distance, that means the light showing us the pillars intact is a millennia-old postcard, a snapshot of a structure that may have been obliterated before human civilization began. By the time the shockwave's destructive glow reaches us, the pillars could be little more than a memory. This eerie disconnect between perception and reality is a hallmark of cosmic timescales. We're not just looking across space, we're peering backward through time. The universe operates on a clock so vast, events we witness as now might have unfolded when mammoths still walked the earth. The pillars of creation embody this paradox, a celestial masterpiece that could be both immortalized in Hubble's lens and long dead in the present. Yet even in their hypothetical demise, the pillars teach us something profound. The same forces that tear them apart, supernova shockwaves, stellar winds, are also the engines of rebirth. The blast that shattered them would have seeded the surrounding space with heavy elements, raw materials for new stars and planets. Destruction and creation are woven into the same cosmic cycle, a reminder that the universe thrives on renewal. So the next time you gaze at that iconic Hubble image, remember, you're not just seeing a photograph. You're holding a relic, a testament to the fragile beauty of existence and the quiet truth that even the grandest structures in the cosmos are fleeting, whispers in the dark etched in light that outlives them. In the summer of 1976, NASA Viking 1 orbiter captured an image that would ignite decades of speculation. A formation on the surface of Mars that, from the right angle, looked eerily like a human face staring upward into the cosmos. The so-called face on Mars became an instant sensation, fueling theories of ancient alien civilizations and buried monuments waiting to be uncovered. Conspiracy theorists ran wild, insisting this was proof that intelligent life had once thrived on the red planet, leaving behind artifacts for us to discover. But here's the twist. The truth behind the face is far more fascinating than any fictional narrative because it reveals something profound about how our own brains perceive the universe. When later missions like Mars Global Surveyor and Mars Reconnaissance Orbiter returned high-resolution images of the same region in the late 1990s and 2000s, the face crumbled into what it always was: a weathered mesa, a natural rock formation shaped by millions of years of wind and erosion. The symmetrical features that once seemed so deliberate were nothing more than shadows playing tricks at low resolution. But why did so many of us see a face where none existed? The answer lies in a quirk of human psychology called pareidolia, our brain's tendency to find familiar patterns, especially faces, in random shapes. It's the same phenomenon that makes us see animals in clouds or the man in the moon. What makes the Mars face so compelling isn't just the illusion itself, but how persistent it remains even after being debunked. Some still cling to the idea that later images were doctored, or that the real structure lies buried beneath dust. This speaks to something deeper: our desire for connection, for signs that we're not alone. The universe is vast and often indifferent, so the idea that another civilization might have left a message just for us is irresistible. Yet the real lesson here isn't about Martians, it's about us. Every time we explore distant worlds, we bring our imaginations with us. From canals on Mars to pyramid-shaped mountains on Ceres, history shows we're quick to project our hopes onto the cosmos. And maybe that's not a bad thing. These misinterpretations push us to look closer, to send better cameras, to question what we think we know. The Mars face endures not as an alien relic, but as a monument to human curiosity, a reminder that sometimes the most mysterious thing out there is our own mind's ability to find meaning in the unknown. And who knows, while this particular face may be a trick of the light, the next anomaly might just be the discovery that changes everything. Until then, the cosmos keeps us guessing, one optical illusion at a time. We think we understand the universe's structure, galaxies clustering into groups, weaving into filaments separated by vast voids. But then there's the Hercules Corona Borealis Great Wall, a structure so enormous it shouldn't exist at all. Stretching an unimaginable 10 billion light-years across, this cosmic behemoth dwarfs everything in its path. To put that into perspective, if you could travel at the speed of light, it would take you 10 billion years to go from one end to the other, a span so vast it defies the very principles we use to explain the universe's organization. Discovered in 2013 by mapping gamma-ray bursts the most violent explosions in the cosmos. This galactic filament isn't just big, it's impossibly big. According to the cosmological principle, a foundation of modern astronomy, matter should be distributed evenly across the universe at the largest scales. There shouldn't be irregularities this colossal, yet here it is, a thread of galaxies and dark matter so immense, it challenges our fundamental assumptions about cosmic structure. So how does something this vast even form? One theory suggests it's the remnant of an ancient density fluctuation, a ripple from the Big Bang that grew unchecked over billions of years. Another possibility is that we're seeing a rare alignment of multiple structures, a trick of perspective making them appear connected when they're not. But even these explanations strain credibility. The sheer scale of the Hercules Corona Borealis Great Wall implies forces at work we've yet to comprehend, perhaps even flaws in our understanding of gravity itself. Then there's the eerie implication: if this structure exists, could there be others? Have we simply not looked far enough or in the right way to spot even larger anomalies? The universe might be far more uneven, far more lumpy than we ever imagined. And that raises a haunting question. What if the cosmological principle isn't a rule, but merely a suggestion, one the cosmos occasionally ignores just to keep us guessing? For now, this great wall stands as both a marvel and a mystery, a cosmic paradox written across the sky in gamma-ray signatures and galactic shadows. Whether it's a statistical fluke or a sign of deeper physics waiting to be uncovered, one thing's certain: the universe still holds structures so grand they rewrite the limits of what we thought possible. And if this is just one of them, what else lies hidden in the dark? Just when we thought Tabby's star was the reigning champion of bizarre stellar behavior, astronomers stumbled upon another cosmic oddity that makes even that infamous flickering sun look tame. Meet VVVWIT08, a star so unpredictable, it doesn't just dim, it practically vanishes, dropping in brightness by a staggering 97% before bouncing back like nothing happened. Imagine a spotlight in space suddenly switching off, leaving astronomers scrambling to explain how anything natural could block nearly all of a star's light. This isn't just another mystery, it's a cosmic magic trick playing out 7,000 light-years away in the constellation Sagittarius, and the universe isn't giving up its secrets easily. At first glance, VVVWIT08 shares eerie similarities with Tabby's star. Both exhibit erratic, extreme dimming, and both defy straightforward explanations. But here's where the new contender steals the spotlight. While Tabby's star dims by up to 22%, VVVWIT08's drops are 5 times more dramatic. These aren't subtle dips, they're blackout curtains drawn across a star, lasting for months before lifting as mysteriously as they arrived. The first time astronomers caught this happening, some wondered if their instruments had glitched. But repeated observations confirmed the phenomenon was real, and the hunt for answers was on. So what could possibly eclipse a star so completely? One leading theory points to a monstrous dust disk, possibly orbiting an unseen companion star or protoplanet. Picture a colossal ring of debris, thicker and more opaque than Saturn's, tilted edge-on from our perspective. As it swings between the star and Earth, it could block starlight almost entirely. But there's a catch. Dust usually scatters certain wavelengths of light, leaving a spectral fingerprint. VVVWIT08's dimming, however, is eerily uniform across colors, almost as if whatever's blocking the light is perfectly solid. That's where the wilder theories come in. Could this be another candidate for an alien megastructure, like the Dyson swarm once proposed for Tabby's star? The sheer scale of the dimming pushes the limits of natural explanations, reigniting debates about engineered objects designed to harness stellar energy. But before we leap to extraterrestrial conclusions, astronomers have proposed another tantalizing possibility: a recent planetary collision. Imagine two gas giants smashing together, their debris scattering into a thick, temporary shroud around the star. The resulting cloud could explain both the depth of the dimming and its irregular timing, cosmic chaos unfolding in real time. Yet VVVWIT08 keeps its secrets close. Unlike Tabby's star, which has been studied for years, this new enigma has only been observed for a handful of dimming cycles. Each event is a data goldmine, offering clues but no smoking gun. The star's resistance to categorization makes it all the more compelling, a reminder that for every cosmic rule we write, the universe enjoys scribbling in the margins. Whether it's a freakish dust disk, the aftermath of a planetary wreck, or something even more extraordinary, one thing's clear: the cosmos still holds surprises that defy our neat explanations. And as long as stars like this keep winking at us from the void, the hunt for answers will never stop. Of all the cosmic accounting errors, none is as baffling as the universe's missing matter, not dark matter, but the ordinary kind. The protons, neutrons, and electrons that make up stars, planets, and even us. Here's the problem: based on the afterglow of the Big Bang, scientists know precisely how much baryonic matter, regular stuff, should exist. But when they tally up all the visible galaxies, gas clouds, and dust, nearly half of it is simply gone. 30 to 50% of the universe's expected normal matter has vanished without a trace, as if the cosmos misplaced an entire dimension of itself. So where could it be hiding? The leading suspect is something called the warm-hot intergalactic medium, or WIM, a ghostly web of superheated gas strung between galaxies like cosmic spider silk. This isn't the cool, dense gas we see in nebulae. It's a plasma so diffuse and scorching, it's nearly invisible. At temperatures between 100,000 and 10 million degrees, the WIM doesn't emit light like a star or absorb it like a dust cloud. Instead, it lurks in the shadows, detectable only by the faintest fingerprints it leaves on light passing through it. Hunting this elusive matter has required ingenious detective work. Astronomers use distant quasars, the brilliant cores of ancient galaxies, as cosmic flashlights. As their light travels through the WIM, specific wavelengths get absorbed, revealing the presence of ionized oxygen and other elements. It's like finding a hidden message written in ultraviolet ink, only visible under the right conditions. Recent breakthroughs with telescopes like the European Space Agency's XMM Newton have begun mapping these whispers of gas, confirming that at least some of the missing matter is indeed woven into this vast, faint web. But the plot thickens. Even accounting for the WIM, the numbers don't quite add up. Some theorists suggest the rest could be tied up in exotic forms, perhaps floating in diffuse halos around galaxies or locked within faint, starless objects too dim to spot. Others wonder if we're misinterpreting the data entirely, that the missing matter might be hiding in plain sight, masquerading as something else. After all, the universe has a habit of being far stranger than we imagine. What makes this mystery so gripping isn't just the scientific challenge. It's the realization that the building blocks of our reality are still playing hide and seek. Every galaxy, every planet, every atom in our bodies is part of this grand ledger, and we're still learning how to read it. Until we solve the case of the missing baryons, we're left with a humbling thought. Even the familiar universe is full of secrets, and some of them might be hanging in the spaces between everything we see. In June 2023, something remarkable happened. NASA sat before Congress not to discuss rocket launches or Mars rovers, but to address the elephant in the sky, unidentified anomalous phenomena, or UAP. For the first time in history, the agency tasked with unraveling cosmic mysteries publicly acknowledged these elusive aerial events as worthy of rigorous scientific study. And here's where it gets fascinating. This isn't just about blurry Pentagon videos. When you connect the dots between UAPs and the universe's greatest enigmas, a tantalizing possibility emerges. Could some of these sightings be linked to phenomena we're only beginning to understand in deep space? Consider the parallels. UAPs often exhibit flight characteristics that defy known physics: instant acceleration, abrupt directional changes, even the ability to move seamlessly between air and water without a splash. Now rewind to those bizarre cosmic events we've covered. Fast radio bursts pulsing with pinpoint precision, rogue planets drifting untethered to any star, or even the eerie symmetries of Hoag's object. The universe is full of natural phenomena that, at first glance, seem to break the rules. What if some UAPs aren't extraterrestrial visitors, but earthly encounters with cosmic anomalies we've yet to categorize? NASA's approach is telling. They've stressed the need for better data, deploying advanced sensors and AI to separate potential breakthroughs from mundane misidentifications. Meticulous methodology reminiscent of how astronomers first verified pulsars or traced gamma-ray bursts. This isn't fringe science. It's the same discipline that decoded the cosmic microwave background and imaged black holes. The irony is delicious. The tools we use to study distant quasars might soon help explain mysteries in our own skies. Yet the hearings revealed something equally compelling: the gaps in our understanding. Physics allows for theoretical concepts like traversable wormholes or Alcubierre warp drives, hypothetical technologies that could bend spacetime to enable rapid transit. While there's zero evidence UAPs utilize these, their reported behavior nudges the boundaries of known physics, much like dark flow or the Great Attractor challenge cosmological models. The takeaway: whether UAPs stem from classified tech, atmospheric oddities, or something genuinely unexplained, their investigation mirrors astronomy's greatest lesson. The universe always has another secret waiting just beyond our current grasp. Perhaps the most profound outcome of these disclosures is cultural. By applying scientific rigor to UAPs, we're not chasing little green men, we're acknowledging that curiosity, not dogma, drives discovery. After all, Tabby's star was once dismissed as a data glitch until closer inspection revealed its true oddity. The same open-minded skepticism that unraveled cosmic mysteries could now illuminate aerial ones. So while we may not have answers yet, one thing's clear: the line between Earth's mysteries and the cosmos is far thinner than we ever imagined, and that's a revelation worth watching the skies for. From vanishing stars to diamond worlds, from phantom galaxies to whispers of alien signals, we've journeyed through 25 cosmic anomalies that defy logic, rewrite textbooks, and prove the universe is far stranger than we ever imagined. Think about that for a second. Every one of these phenomena, whether it's the Great Attractor pulling galaxies like a hidden puppet master, or rogue planets drifting alone in the dark, challenges our understanding of reality. And here's the wildest part: this is just the beginning. For every mystery we've uncovered, there are countless others lurking in the void, waiting for the right moment to shatter our assumptions all over again. What ties these bizarre events together isn't just their strangeness, it's the humbling reminder that we're still cosmic beginners. Our telescopes peer deeper, our probes venture farther, yet the universe keeps surprising us. The WOW signal vanished without a trace, Tabby's star flickers like a broken street lamp, and dark flow tugs entire galaxy clusters toward nothing. These aren't just puzzles, they're invitations. Invitations to stay curious, to question boldly, and to embrace the thrill of not knowing, because that's where discovery lives, in the gaps between what we understand and what we've yet to imagine. So here's the real question: what's next? With next-gen observatories like the James Webb Space Telescope and the Vera Rubin Array coming online, we're on the verge of revelations that could make today's mysteries look like child's play. Maybe we'll finally decode fast radio bursts or catch another interstellar visitor like Oumuamua. Perhaps we'll stumble upon a phenomenon so bizarre it makes the Hercules Corona Borealis Great Wall seem ordinary. The universe doesn't run out of surprises, it runs out of ways for us to predict them. As we wrap up this cosmic tour, I want to hear from you. Which of these 25 events left you staring at the screen, rewiring your brain to make sense of it? Was it the zombie stars that refused to die, or the ghostly whispers of the missing baryons? Drop your favorite in the comments. Let's geek out over the universe's weirdest wonders together. Because the best part of science isn't having all the answers, it's the collective awe of asking the questions. And who knows, the next great cosmic mystery might be hiding in plain sight, just waiting for someone like you to notice it. Keep looking up. The universe isn't done astonishing us yet.